Hello, this is Austin. So I was going to go over descriptor tables, basically logical and linear addresses. This is all part of understanding the Linux kernel book, and I just kind of want to go over it, kind of like briefly go over it, but not in like a huge amount of detail. So basically, when you're talking about memory, um, and we're talking about how your computer accesses that memory, within the CPU, there's different ways of it going through accessing that. Um, you know, accessing the physical RAM chip. So there's logical addresses, there's linear addresses, and there's physical. So there's three different types of addresses, and your computer goes through these three in different ways. So when you're programming in assembly, usually I think you're using logical addresses. Physical is like the your like the electric circuits in your RAM um, use physical addresses, and then to store. So your computer does this thing where it has this how do I explain it? Segmentation registers. And if I explain this, then when I start saying it, you might kind of like, if you've done any assembly programming, you might kind of know what I'm already saying. Um, so there's you either have a local descriptor table or a global descriptor table. Okay, and basically, um, a descriptor kind of it holds a descriptor table holds descriptors, um, and we don't even I haven't even gone into what descriptors are yet, but I will here in a second. Um, there's so a logical address has two different parts. It has a segmentation identifier and then offset, right? And then segmentation identifier, which is also called the segmentation selector. The bit field kind of looks like this. It has index, and it has TI table index. So this table index determines whether it's part of the LDT table or the GDT table. And then there's also their request privilege level. So on Linux, there's different privilege levels. Well, on any operating system, I believe it's um, I think it's the CS register. Yeah, I believe so. Um, Actually, don't quote me on that. But anyways, there's different privilege levels. Forget what I just said earlier about the code register or CS register. But there's levels 0 through 3 about for privilege access. Linux only uses two of those levels, so 0 would be the kernel. Uh, you, whoops, kernel mode, and then level 3 would be user mode. And then yeah, so RPL basically says, oh, what privilege level is this? So what a segment this segment selector part of the logical address. And then so yeah, so this is 16 bits long, and then there's an offset right here, which is used later, which is 32. That's a terrible 32 bits long, which I'll kind of go into a little bit later here. A descriptor has a whole bunch of different things in its bit field, but I'm just going to go through something kind of simple. And when, you know, the book, Understanding Linux kind of goes through, Understanding Linux Kernel kind of goes through. There's different types of descriptors. There's actually, before I go into the descriptors, let me talk about the segment register. So I just talked about this right here. This is all of this. This bit field is the logical address. Bit field. I really hope I'm recording. Yeah, it looks like I'm recording. Okay, so that's the logical address bit field, which what I've just been talking about. But so there's see this thing right here, this part of the logical address, this first part. That's not the offset. This section that I'm circling over and over again. Maybe I'll do it in a different color. Ooh, it's kind of hard to see now. I'll highlight it. This part of the logical address, that CS. Whoa, let me change the color back. Is there an undo? Undo. Let me change this back to black. So there's a CS, the code segment selector, which points to the code in your program. Then there's the SS, the stack segment register, which points to the program stack. Again, this is kind of like assembly, kind of goes through this. So when I say points to code, stack. When I say points to code above here, I mean right here, I mean like the instructions. And then there's the data segment, which is global static data. Okay. And then before I go into anything else, yeah, I told you that the table index either talks about the local. This is the local descriptor table, and this is the global descriptor table. So normally you only have one global descriptor table, and then usually like a process can choose to make a local descriptor table. It doesn't always choose to do that, but you know, sometimes it does. I'm going to make a new page here. So the LDT, going back into LDT and GDT. LDT, so there's two things stored in LDT and GDT. There's registers for LDT and GDT. There's the LDTR, so that's the local descriptor table register, and then there's the GDTR, the global descriptor register. So I think from what I understand is that, let me read through this again. So these both contain address, and size. So it contains basically the base address, the starting address of the table that it needs to go into. If that makes sense, and then it also has the register also has the size. Yeah. And then from here, let me go. I'm not going to go exactly through how the book does it. So we just talked about segment selectors, right? And then kind of like descriptor tables, but we didn't really go through how they kind of relate to each other. So a segment selector, as I was talking about before, there's this index part to it, right? I'll highlight it another color. Oh, that's not a highlight. There's this index part to it. Highlighter. This index basically points to the descriptor table, which is LDT or GTT descriptor table. So you got right here, you got right here your segment selector, which points to your segment descriptor. The segment selector, the index. So the index part of the segment selector points to the segment descriptor that's in the descriptor table, which could be any of those, the LDT or GDT, and that points to a segment, right? And then also, so this is, right, anytime a segment is created, like, or anytime a segment selector pulls up a segment descriptor, here, I'll read it right from the book. Every time a segment selector is loaded in a segmentation register, right here, every time a segmentation selector is loaded into a segmentation register, the corresponding segment descriptor is loaded into memory. Is loaded from memory into the matching non-programmable CPU register. So each of these basically descriptors also have a non-programmable descriptor. So once this is loaded into a segmentation descriptor register, which is this, then also another non-programmable register is created. That points to that same descriptor, just so it can access it faster when it needs it. Now let's go into how to access from that. We've been talking about, this is all logical addresses. Now getting from the logical address to the linear address, how does the computer do that? So let me add a new page. So in the book, it kind of goes through this. So let's go back through. So this is a selector, right? This is the logical address, right? Here at the bottom. I'm going to put this logical address here at the bottom. And it has, so it has three fields, the index, the table indicator, and the RPL, but I'm just going to show two of them. The index and the table indicator, because that's how we need to use this. And these last bits, which is the 32 bits. So this is the 16-bit, whoa, it's not highlighting. That is, I didn't hit the highlighter again. This is the 16-bit part. And whoa, undo again. and this is the 30. I keep forgetting to hit the highlighter. 32-bit part right here. 16-bit in blue, 32-bit in gray. This is all the linear address. So this is just the offset. And we'll see what's happening here. So the thing is, this index, right? This index part of the logical address, it's actually, so each descriptor is 8 bits long, right? Or 8 bytes long. I'm sorry, not bits. 8 bytes long. So in order to get these indexes are not, they don't go 0, 8, 16, right? So in order to get the actual address in the table, we'll have to multiply these indexes by 8. So boom, you can do times 8 right here. I'm literally just copying this from the book, so but just explaining it in words. Then we have the GDT, global descriptor table register, or the either or, whichever one is defined by this table indicator. And I'm going to see if I can move all this down real quick. It's kind of getting in my way. I'm kind of running out of space here. See how far I can move down. Yeah, I'm just going to move all the way to the bottom here. Good. So, yep, so this table index either points to the GDT, global descriptor table register, or the local descriptor table register. And remember I was talking about the base address, so this will point to the base address. What we need from here, right here, in order to get the linear address is the base address. That's what we need from there. We're not worried about the size. But then we take the base address, right? Let me erase this plus sign I made up here. We take the base address, add it to what we already had to get our position in the descriptor table. So that's either a global descriptor table or a local descriptor table. Boom. So we're like, oh hey, we got the position, the descriptor, and the table. And then from here, even though we got the descriptor, we still don't know the logical address, right? And we get that logical address by taking the offset that was in our, we get the linear address by taking the offset that was in our logical address and adding it to the position of the descriptor to get our linear address. So I literally just went through the book in explaining this. Yeah, so I'm going to go through this again. I eventually want to get to paging in memory and virtual memory and other things like that. So yeah, if this was helpful, give it a thumbs up, subscribe, whatever. Thank you for watching.